Hi, everyone. Thank you for attending our session at the BU Data Science Day on industry-enabled data science research. So my name is Yorgos Zervas. I'm an associate professor of marketing here at Questrom, or I should say downstairs at Questrom. And we have put together a session that consists of 3 talks by Questrom faculty with very diverse backgrounds and experiences, followed by a panel that will focus on the opportunities and challenges in doing data science research now and in the future. Our session is also attended by our wonderful Masters of Business Analytics students that you might see around here. So that speaks to the pervasive nature of data science. So a year ago, we launched this program to train young students in data science, and we have 86 students this year who are attending our session, and in fact, the entire day. So the first talk is by my colleague, Gareth Johnson, who joined us 2 years ago from Northwestern here at BU. Gareth is an expert in researching digital marketing and advertising, and this will be the subject of his talk today. Gareth's work has been very well cited, and in fact, the work he's presenting today won the Best Paper Award in 2017 at the Journal of Marketing Research, which is one of the most prominent journals in marketing and all of management. So without further ado, I will invite Gareth to present for his talk. The format is 15 minutes per talk, approximately 13 for the presentation, 1 or 2 for Q&A, and then we'll have our panel. So Gareth is our first speaker.
All right. Well, it's a pleasure to be here, and it's a pleasure to represent Questrom. I think Questrom is doing some tremendous research in data science, and as Yorgos mentioned, I think we're also leading in the teaching dimension. We've got this new data science master's program. Those of you who are the MSBAs, would you raise your hand? So if you have any questions about the program, you just saw 80 people that you can ask about it. All right, so today I want to talk to you about measuring ad effectiveness at scale using a methodology we developed called GoStats. So our story begins, as many good stories do, a long time ago in a galaxy far, far away on the Macy's website, where I was looking for articles of clothing with Star Wars-themed stuff that I could purchase, and I happened upon this piece of clothing, which is a Darth Vader one-piece pajama suit. Now, gaze upon this and just be marveled by how you could get that much value for only $49.99. And so I thought long and hard about this, and I thought long and hard about my marriage, and I decided not to purchase. And afterwards began a series of just incredible coincidences. So I visited my favorite hockey website, and there I saw not only 1, but 3 ads from Macy's, and each one of those had the Darth Vader one-piece pajama suit. At this moment, I'll mention that I'm Canadian, and this is my favorite hockey team. And then even when I visited my own paper on the subject, I once again saw the Darth Vader one-piece pajama suit. So I think that we're all familiar with this string of unexpected coincidences. It has a name, and that is retargeting. From Macy's perspective, the journey that the customer is going on is the customer starting at their website, browsing a product, perhaps putting it in their cart, but they're not purchasing. And after that fact, Macy's starts to show ads that may or may not have that product in them at unrelated websites. So in this case, OilersNation.com and SSRN. Now, at the end of that journey, the consumer is going to make the decision to buy or not buy. But if you're Macy's, what you care about is the return on investment on your advertising. And so for you to understand what is the return on that investment, you need to understand what would happen if Macy's had not advertised. And this is especially crucial in this occasion because someone that's browsed a Darth Vader one-piece pajama suit is about 2 million times more likely to buy that than someone that hasn't. So in science, we have ways of solving this problem, and that's through using a randomized experiment. And increasingly, that's what industry is starting to do. And so in a randomized experiment, you have this user going through this experience of seeing ads, but you also have their identical twin who's in the control group, has the same experience, but doesn't see the Macy's ads. And then there's a question of what ads do they see instead? And traditionally, the way we've solved this is we show them an ad from an unrelated advertiser, often a public service announcement, like in this case, an ad for the Red Cross. And then at the end, we compare the sales for the people that saw the Macy's ad to the people that are identical, but for the fact they see the Red Cross ad. So now we get to what are ghost ads. And to get there, it helps to understand what they are not. So first of all, traditional way of solving this problem is to show these PSA ads. So if you imagine a user in a treatment group and an identical twin in the control group, each one of them visits 3 websites, sees an ad on each site. The treatment group user is going to see a Macy's ad, then something else, like maybe a Starbucks ad, and then another Macy's ad. And the control group user, that Macy's ad is going to be swapped out for a Red Cross ad. And so they're going to get the same experience with that focal ad swapped out. So this is a traditional way of doing things, but it has several problems. One of the main problems is that it's expensive. If you're spending $5 per ad on the treatment group side, you need to be spending $5 per ad on the control group side. And this is a real challenge for scaling. To put this more dramatically, no advertiser in the history of advertising has ever said they want to spend half their ad budget on PSAs every time they run a campaign. Now, of course, I'm being a bit glib here, but this highlights the problem that they face in reality, that yes, the experiment is a clean way to get the right answer, but if we're going to do things the old way, it's just never going to scale. No one's ever going to want to do this as part of everyday business practice. So then you may say, well, why do we need these Red Cross ads at all? Maybe we should just show them the next best ad. So in place of the Red Cross ad, the control group user now sees a Zappos ad in the first place and a Disney ad in the third place. And this is actually kind of desirable because when Macy's is trying to understand the impact of their ads, they need to understand the role that their ads play in pulling people towards their ads, but also the role that their ads play in blocking their competitors from showing ads. So in this case, maybe Zappos could be construed as a competitor. After all, the Red Cross helps a lot of people in need, but it does not rescue Macy's customers when Macy's chooses not to advertise to them. So what about the next best ad? Well, if we were to look at the data from this experiment, we would know in the treatment group user that the treatment user was exposed to 2 Macy's ads. But then if you look at the control group user and you look at the ad log of their experience, you just see that they were exposed to 3 unrelated ads. So you don't know how many Macy's ads they would have seen. In fact, you don't know that they would have been exposed at all. And so now we see the work that these Red Cross ads were doing initially for us, albeit at great expense. So our solution is to use some Pac-Man ghosts. Now, our solution is to realize that the first and third ad in the control group are special. They're special because they were the ads that would have been shown as Macy's had that user been in the treatment group. And so what we're going to do is we're going to create an additional database, and in that database we're going to record all the times that the control group user would have seen an ad for Macy's. And so now we have this nice balance between recording actual exposures in the treatment side and recording the exposures that would have happened, or the counterfactual exposures, in the control group side. So a ghost ad is just a log in this database that tells us these would-be experimental impressions. Now, when we were thinking about the name for ghost ads, we were thinking as marketers, how are we going to kind of create a name for this? And we decided on ghost ads because it's a metaphor. Now, the first part of the metaphor is that ghosts are invisible. And in this sense, a ghost ad is never an ad. The consumer can never distinguish between which of these ads are actually ghost ads. That's invisible to them. But ghosts can also possess things, and we know this from watching any Ghostbusters movie. So in this sense, the first and the third ad are possessed because the experimentation platform and we as the analysts know that those ads are special. And the last part of the metaphor is the word ad, because again, a ghost ad is, properly speaking, not an ad, but if you're going to be an analyst working with this data, the ad database is going to be functionally equivalent to the Ghost ad database. So this is going to be helpful, and it's going to solve a lot of problems. And this has actually been used at scale in industry. So we first implemented this methodology at Google. They have two products that use this, Conversion Lift and Brand Lift. Sort of as they say, Conversion Lift is going to say, does an ad cause you to change your behavior online? Whereas Brand Lift is, are you going to change your answer to questions like, are you favorable towards Doritos? And a lot of advertisers have made use of this. So these are a list of companies that have published public case studies with Google. On the brand lift side, we see automobile manufacturers, we see banks, we see movies, we see fast food companies. And on the conversion lift side, you even see that Google saw fit to use this for their own purposes, for understanding the impact of their Chromecast advertising. And actually, this methodology is used very broadly at Google alone. So, and every day, there's over 1,000 campaigns running that make use of Ghost ads. In total, there's been millions of dollars in ad spend that have made use of this, and the experiments have amounted to billions of user observations. So, in that sense, Ghost ads is passing the McDonald's test of billions and billions served. Finally, this platform and this methodology has expanded beyond Google to use to many other companies in the space. These are kind of large ad platforms, though you'd probably recognize the logo of Netflix. They're a real leader in using this technology. A couple of these companies, DataZoo and Nanigans, are local and doing some excellent work trying to optimize for the incremental effects of ads using this methodology. So going back to our story before of retargeting, one of the questions we had is, does this actually work? And I want to briefly discuss two case studies that made use of this form of advertising. So the first case study was a company that prefers to be anonymous, but I affectionately refer to them as Sportsing. They are a sporting and outdoor goods retailer, and they saw an increase of 10.5% in sales during the experiment. The second advertiser is Def Shop, and they are a European-based streetwear and hip-hop clothing retailer. And what they saw was a 12% increase in their sales caused by the ads. So the takeaway here is that actually 90% of the sales after people see these ads would have happened without the campaign. And this makes sense because you're showing ads to people that are already visiting the website and that already are putting things in their cart and probably are already going to buy. So there is a very real lift there, but if you were naive and you just said that any action people take after they see an ad is caused by the ad, then you'd overstate the true effectiveness of the ad by 10x, which would lead you to a really bad business decision. All right, so I'll stop and leave a couple time for questions.
So we have a minute or two for questions. Okay, let's thank the speakers.
Oh, thank you. Thank you. Go ahead at the back. So you can block ads and you can block trackers, but this is not something that uses necessarily tracking technology. So the same rules that would apply to show you a regular ad would be what apply to showing you a ghost ad. And a ghost ad is, again, not a real thing. So nothing to be too afraid of. At the back, one more question? No, I think that one of the challenges in this setting is to get valid experimental estimates. And when we do those things, the estimates we get are exceedingly noisy. So we have another paper looking at 400 of these experiments, and the median lift in site visits was 16%. Is that big or small? Well, there's some TV ad work showing somewhat similar lifts, but that was also 30 years ago. So we're all learning. This is still pretty greenfield. Surprisingly enough for the marketing field.
Okay. HDMI or...
So our next speaker is Matt Marks. Matt is an associate professor of strategy and innovation and a Dean's Research Scholar, also at Questrom. And he's an expert in studying the mobility of knowledge workers and the commercialization of science and technology, i.e. the stuff that we produce here at BU and at Questrom. This is often very important because you might have seen two examples of two great pieces of research where the researchers managed to engage with industry because there was something in it for industry. But for us, it's not always the case that we can convince industry partners to work with us during a potentially long project with an abstract goal. So Matt has done a lot of work in understanding how the products of universities are incorporated in industry, which is sort of the reverse perspective of what we have been discussing here. As part of his work, Matt has put together an impressive data set using BU data science resources that he will be talking about today. Finally, the last thing that I will say about Matt is that Matt is a member of the steering committee of the Innovation Information Initiative at the National Bureau of Economic Research, which aims to level the playing field of research by making publicly available many data sets that researchers can use. So, Matt, the floor is yours.
Thanks. All right. So, don't clap yet. I didn't do anything. That's fine. I didn't do anything yet. So I want to talk about a question that I think is on the minds of many researchers in this room. And it's certainly on the minds of the people who give us money, that is, foundations and governments who plow tens of billions of dollars into academic institutions. And the question on their mind is, what are they getting besides advancing our personal careers? What does it make? What difference does it make? Because there's a risk that maybe if we just write papers that nobody reads, or papers that are just cited by our own friends in the discipline, that it's like that tree falling in the forest that nobody hears. How can we measure impact? And what do I mean by impact? Here's one example. Does anyone know Amnon Shashua? Does that name ring a bell for anyone? One person out of this entire room. Different question. Does anybody drive a car that has lane departure warning? Raise your hand. Pedestrian collision detection, anything like that? Probably most of you. If you do, there's an 85% chance that your car has Amnon's technology in it from a company called Mobileye. Now, Amnon's a professor of computer science at Hebrew University in Jerusalem. He's published hundreds of papers on the use of machine learning and computer vision for pedestrian detection, for collision warning, things like that. And he could have chosen just to kind of publish those papers and see what happened. He didn't do that. Instead, he co-founded a company, Mobileye, that you've never heard of, but was acquired for $15.7 billion, the largest Israeli acquisition in history. And that was his method of having impact. The question is, how can we tell when this sort of impact happens? Historically, there's been two ways to do that. One is to grab survey data that's compiled by the Association of University Technology Managers. And what they'll do is they'll give you a count of the number of licenses done at University X and a count of the number of startups. But you can't see the names of the startups or what the licenses were, what the technology was. And by the way, it's only for North America, and then not even for all the universities. So the data is not that great. Now, if you want great data, what you do is you talk to my friend Mike Pratt from our TLO office, and he'll be on the same panel. And Mike will tell you not just how many, he'll tell you what the startups were, who the licensees were, what the technology was, who the PIs, great data. What's the problem? The problem is you have to talk to Mike's counterpart at thousands of universities around the world. And every few years, someone tries to do this and they give up because it's just insurmountable. So we have a different kind of big data approach to doing this. And we are able to do this because of an obscure thing you've never heard of, and you can't really read this, but in 1946, the U.S. Patent Office said if you want a patent in this country, you have to cough up the prior art. You have to tell us what patents, what websites, what product manuals, and most importantly, what scientific papers did you rely on in developing this invention? And given that patents now cite not just other patents, but they cite research papers, we can use that as a paper trail to look at the utilization of academic science by industry. Let me give you an example. So this is one of the several CRISPR papers, and you'll see that the famous Jennifer Doudna is the lab manager at the final author position. And Blake Weidenheft is probably the postdoc who did the work. Keep those two names in mind, because I'm going to show you now a patent. So this patent also has Jennifer on it, and this patent cites the paper I just showed you. This is listed as prior art on the front page of the patent. And so you look at this and you're like, okay, so Jennifer wrote this paper. Now she's doing a patent that references, so maybe she's actually commercializing this science. Indeed, this is a patent assigned to Caribou Biosciences, which is a startup founded in 2016. And if you dig a little bit, you'll see that Jennifer is not just on the SAB, but she's a co-founder of this company. And so we say, okay, there's impact. That's how we can track this without calling up thousands of Mike Pratts around the world, and we can actually see the kind of the heritage of this technology. Now, I'm oversimplifying a little bit, because if you looked at this patent and you said, oh, well, this is easy. I see the author name, I see the title, I see the journal, I see this biblio information. Just extract those fields and let's do a database join on the Web of Science and we're done. But there's a problem. First, you don't always have the title. Sometimes you just have a few words. You get this abbreviation for Nature Biotechnology. I don't know why they put the slash in there, but they do. Is 12320 the volume and issue, the volume and page, the issue and page? We don't know. Sometimes they give you the title, but they didn't close the quotes and they kind of left out the middle of the title. And you're wondering, is the author Kim K.J. or is it Kim K. and then it's Journal of Vascular Science? Technically, you don't know. And there's like 200,000 journal abbreviations. Sometimes they put the journal first. So any type of attempt to extract structure from this is really tricky. And so we brute force it. And so we start with 150 million scientific papers that have been published, and about 40 million of these references on the front of patents. Now, if we matched every one of those, that would be about 6 quintillion comparisons, and our first version of the algorithm was projected to finish sometime in 2024. But thanks to Aaron Fuji, my partner in crime here, we came up with a posting table approach where we make millions of subsets of the prior art sites and just compare, for example, the sites that have the word pathogen or polymer against papers that have that word in the title. And so we essentially run tens of thousands of comparisons in parallel, and we can run this in about 4 days instead of 4 years. And we do it on the highly amazing shared computer cluster. If you're not using it, you need to use it. It's incredible. And by that way, we can chew through this data. Now, I present this sometimes, people say, but wait a second. I go on Google Scholar, I type in my paper, and I can see a patent site in the paper, and that's true, but if you want to analyze this data, you can't download Google Scholar data. You can't even pay them for it. They won't give it to you. Moreover, Google Scholar doesn't do this, which is that there are a lot of these scientific references not nicely formatted on the front page, but stuck in the middle of the body text. In fact, this one paragraph from one patent has about 12 different references. Here's one of them, Cohen et al. There's no title or anything. You have IBID pointing back to that, which actually means reuse the author and the journal, but not the year, page, and volume, because I gave you new info on that. And then you have IBIDs pointing to IBIDs. It's a mess. And so what we do is we look through terabytes of patent text to find years, like 1976. And we see 1976, we say, okay, build a window around that. Maybe there's a reference. And we push that through the shared computing cluster. And they have to be careful because sometimes 2000 is Windows 2000 and not a reference, but we have kind of false positive detectors for that. Again, I tell this story, people are like, well, why didn't you just build a classifier and train it to do this? And we did, and it kind of works. It finds about 2/3 of the references that we find with our heavy-duty methodology. But what do we get for all this work? Well, for one thing, we can make a worldwide index of university science-based ventures. And so this is just year by year. Most of these are in the life sciences, but also in IT, other physical sciences, and engineering. And they roughly track the global macroeconomic trends in terms of the tech bubble, the bursting, the Great Recession. And so we have this data now. The question is, what can we learn from it? What predicts when a professor takes her discovery and then commercializes it? And for that, we have a problem, because there are about 150 papers out there that do this, not with this data set, but they try to infer what are the factors that matter. And the problem is, if you take two research projects, the problem is you might get one that is, say, the RSA encryption algorithm, which was invented at a university, or Google PageRank, or the e-ink screen on your Kindle, and the other paper is some boring thing I wrote that no one ever cared about, right? It's an apples and oranges problem. And there's this unobserved latent commercializability that we just can't know ex ante. So what do? Well, what we do is we look at duplicate discoveries, which happen a lot in the hard sciences. So if you look at the titles of these two papers, they're both about the BID protein, which is related to cell death, also called apoptosis. And if you look at these titles, you might say, well, those sound kind of similar. And if you could read the abstract, you'd say, wow, those are really similar. And if you read the whole article, you'd conclude the same thing that the scientists did, which is that these are the same discovery. In fact, they're so similar, they were published back to back in Cell magazine. And you might say, wait, why do editors do that? They do it because they hate retractions. Last month, the Nobel laureate announced that she was retracting a paper. No one likes retractions. And so independent verifications of the same finding are really key. Now, to find this is a long algorithm, but the key is that we look for papers that are cited together, not just in the same paper, but in the same parenthesis, over and over. This is Susan Cousins' approach. And to do that, we have to read the PDFs. And so we don't do any firewall trickery. But what we did is we contacted Google Scholar and said, can you just give us the publicly available PDFs so we can analyze them? And they said, keep talking to the hand. We won't give you our data. So I built a server farm in my basement, and over a period of 19 months, we scraped hundreds of thousands of publicly available, totally legal, PDFs from Google Scholar and found 20,000 of these duplicate scientific discoveries. Now, when we analyze the duplicate discoveries, what's great is we're looking at the same science. And the question is, well, what matters? What we found is what doesn't matter is the usual suspects. It's not that high-status professors start startups. It's not that people at high-status institutions are more likely to commercialize their science as startups. It has nothing to do with the proximity to venture capital. If you do it in the cross-section without the twins, you think all these things matter, but there are big selection effects. The question is treatment. So what does matter? Two things. First thing is that mentorship matters a ton. If someone on your project has previously worked with someone who founded a startup based on their own research, you're about 10 times more likely to do that yourself. Dramatic effects. The other thing that matters is interdisciplinarity. So what this is a predicted probability of commercializing your own startup based on how interdisciplinary the team of scientists is. On the left-hand side is everyone works in the very same field, and on the right-hand side, everyone's coming from a different place. And their chance is about 3 times higher than when everyone works in the same field. So the next time you get a note from your department chair or your dean or from Bob Brown saying more interdisciplinary research, please, don't roll your eyes. Think about this slide, okay? Now, I've talked about startups mostly, but this affects big firms as well. Consider, for example, a biotech company in San Diego looking for new discoveries, and they see that there's one of these duplicates that's in Dallas at Southwestern Medical Center, high-status institution, and then one that's up here in Boston somewhere. The work on geographic spillovers and distance would tell you that they should utilize the one that's in Dallas. But there's another important factor, not just the proximity to the biotech company, but to all the companies doing R&D in the narrow field of this paper. And when you consider not just the one firm, but the hubs of research and R&D, you see that this fact reverses. And people reference the paper that's much further away, but it's clustered with a bunch of companies doing the same research. And moreover, this effect decays over time. It's stronger at the scientific frontier, where there's more uncertainty, where people are less sure where to pay attention. So anyway, I need to wrap up because I'm out of time. Let me just leave you with the data. If you're interested in using any of this data in your own research, everything we've done is publicly available. So at relianceonscience.org, we've posted all of our patent-to-paper citations. As of this morning, we've had about 6,500 downloads. Dozens of researchers around the world are using this. I got an email from France yesterday. And as part of this, we've created a new metric for research. So everyone's familiar with the journal impact factor. So how many citations do I have from other academics? We've something called the journal commercial impact factor. So not how many citations from academics, but how many citations from patents assigned to commercial firms. And so I'm hoping that these data can help us get a better view into how university science is utilized by industry. Thank you. Any time for questions? We do? Okay, great. But we have no questions, so no problem.
Or we can take questions.
Do you have a sense of how the uncertainty in your upstream processing impacts the downstream? Because you're using all kinds of techniques,
Mm-hmm.
matching and scraping and all that.
Mm-hmm.
So there's presumably some error there.
Oh, I'm glad you asked about that.
Do you have a sense as to how much and how that's propagating downstream?
Yeah, we do. And I didn't take time to show this, but if you were to go to our website and grab our data, what we do is essentially we plot receiver operator curves for false positives and false negatives at several different confidence levels. So every match will get a score from 1 to 10 in terms of how sure we are. We've never seen a 10 that's wrong. Occasionally a 9 will be wrong. When you get down to 3 and 2, most of them are wrong, so we kind of take those out. But yeah, we do extensive error testing, and we have that done by a third party so that I don't overfit the algorithm to the test set. Thank you for asking. Okay.
All right. Thanks again, Matt. Next, I would like to give the floor to Mark Scatamakia and Mike Pratt, or Mike Pratt, who work respectively for the Offices of Industry Engagement and Technology Development. So Mark is the Associate Vice President of Industry Engagement Research and Support, and a lot of what he does is actually help faculty do work with industry. So he facilitates industry interactions. You learn a bit about Mike's work through Matt's talk. So Mark and/or Michael will spend a few minutes introducing the work that they do here at PU to support our work with industry, and then we'll have our discussion.
So, thank you, Yorgos. We're very happy to be part of today's session. You may be wondering why we're here. We're not faculty, and we don't have compelling research to show you. But one thing that you did learn in the preceding presentations was a lot of work with industry, how industry can help support faculty and how it can advance their research. And you also heard a lot about the impact that your research can have as it is commercialized and becomes part of society and benefits society. So what Mike and I do is help to support that work. The university wants to make sure that your partnerships with industry work well, they're efficient and fruitful. We also want to make sure that your interests and the interests of the university are secured. So we'll talk a little bit about my function. So I lead industry engagement. And it is our goal to help create sort of long-term strategic value-creating relationship with industry. We primarily help with outreach to industry, help you make the connections between research that's done within the university and industry that is interested in that research. We have subject matter expertise in our office with people that are familiar with your research but have worked on the industry side of things. So they understand how industry thinks and what industries is going through their heads when they're engaging with the university, and it helps us to figure out how to find those areas of intersections where industry can support the research. Our main goal is to help you create industry-sponsored research programs for your research and laboratories. We also create consortia. We just started one with Hariri, the Data Privacy Consortia, just a month or two ago, which are other ways to have industry help support your research. We also work on corporate relations side, so gifts and philanthropy, because we often find that research is interested in giving a gift to you or your laboratory as part of the first step in creating that relationship that could lead to sponsored research. We do a lot of other stuff as well. We do the supporting agreements associated with sponsored research, so incoming material transfer agreements, classification, confidentiality agreements, data use agreements, equipment agreements, that sort of thing. We can help you support and organize industry visits to your laboratory or you to industry. And we also have some support services, supporting services as well, where we help with Mike's team, researchers that are looking to commercialize their research on their own through entrepreneurial services. And we also support, oftentimes, industry is working with us because they're looking to employ our students or provide internships for our students, and we help make those connections as well. So that's a little bit about what my office does. Mike, who you already have a preview of, and you already saw his picture, in fact, will talk about his office.
Thank you. Thanks, Mark. So it's really pretty straightforward. I mean, our office really focuses on patents and licensing, but of course we get involved with all sorts of intellectual property questions that come up. Many times the classic scenario is you're engaging with industry, you're working with Mark's group, but some very narrow questions come up around intellectual property, because sometimes these companies, even though they're sharing their data with you, might want to put restrictions around patents, for example. If you invent something with my data, these are the restrictions we want. And then we all have to ask the question, is those the right, proper restrictions that we want to accept? Does it affect academic freedom? Is this going to affect my students' ability to publish? Is this going to somehow interfere with other collaborations I might want to do with industry? And we can help you work through some of those issues, although admittedly, You're on the vanguard of a whole new frontier as data becomes a commodity, right? Something we can all work to trade and trade in the marketplace. The laws are always behind science, right? In progress, right? So there's not really good legal frameworks for data, right? There's no patents that protect data. It's really about access, and we can talk about that a little bit more in the panel. So we have to be creative. As you guys go forward and move the frontier forward, we're gonna have to react and be more creative in the way we work with industry and the way we come up with new ways of sharing these things. And I'll turn it back to Mark.
Yeah, sure. And we just wanted to leave you with one last sort of picture, which doesn't look anything like that in my slides. They're really nice hexagonal tiles, but contact me. I'll send you a nice version of this chart. But industry engagement is a relatively new function at the university. About almost a year and a half now it's been, and I'm new as well. So I started this function when I joined the university. There are lots of organizations within the university that reach out and work with industry. And we just wanted to leave you with the fact that one of the things industry engagement strives to do is be that focal point, that node, to help you figure out how to work with industry, regardless of where ultimately that industry relationship may lead. So working with development, for example, on the upper right, sponsor programs on the upper left, the centers and institutes like Hariri, we do a lot of work with Hariri. Career development, as I mentioned, internships and hiring. So there's lots of ways, there are lots of offices that work with industry at the university. Industry engagement can help be sort of that node to help you figure out how best to do that work.
Thank you.
Thanks.
Is that a question already? Oh, wow, perfect. Yes, please. I was going to ask a question, but I was going to say I encourage the audience. Please.
Oh, thanks. It's a question mostly for Mike, but also partly for Mark. So I'm the open source guy, and my question, of course, is going to be, how do you find the relationship with industry changing as more and more companies like Red Hat, where I work, embrace open source methods and aren't necessarily interested in taking IP and locking it up? What is that having an effect on what happens in the university and industry relations, and what is it?
I'll go first? Yeah, sure. So first of all, this is a great audience for open source because that's our first choice, right, is to make things publicly available, both through our policies, our data policies, our intellectual property policies, clearly states that putting things in the public domain is our first choice, right? And sometimes in certain fields, like pharmaceuticals, I think is a good contrast, which I was talking with my panelist here. If we don't have a patent around a molecule that's going to become a drug, no drug company will develop it. And that's unfortunate because that drug could help people, but minus a patent, it just won't go forward. So if you think of the goal of the institution, impact, right? Our number one form of knowledge transfer is the students we educate and graduate. That's the first kind of form of transfer. We could argue publications. Okay, maybe publications is more of an impactful than graduating students. I'm not sure. I don't have any data to support either case. But they're both very impactful, and that's either first and second or second first, whichever order you want to do it. A very distant fifth or sixth or seventh is this idea of transferring things through a patent or technology transfer license. It's a very small amount of the work we do. And in the case of open source, if the biggest impact comes through open source, wonderful, that's great. That's resonance between the university community and industry community. So I see that as a big plus in only growing what we can do in creating more impact. The limited cases of patents and stuff like that will still be there for certain types of products.
Yeah, and I would just add, Red Hat's a terrific example of how industry can work with the university in open source software areas, right? So working with industry may lead to patentable inventions going forward, but that's often relatively infrequent in terms of sponsored research. What it does lead to is new knowledge and innovations that can be used by the industry sponsor to help them in the competitiveness in the marketplace and help to advance the university's research. And those relationships work really well in the open source arena.
I wanted to ask a question, and I encourage people to step up to the mic to ask questions so that they can hear you. So I had a question for all of our panelists and our faculty here, and that stems from my own anxiety in doing work with industry. And I often wonder, should we be doing that in the first place? it's difficult. Partners can be finicky. They can disappear, and then a lot of work goes to waste. It alters the perception of this work sometimes. So if my work is sponsored by Google and I publish something on advertising, or if it's sponsored by a bank and I work on delinquency, how is my intellectual independence perceived? And how should we be thinking about those things? So there is a lot of work and thought that goes into working with industry. And I wonder, what do we gain in return? So why have you chosen to work with industry? What are some of the challenges you face? And how can you facilitate that process? So that's my broad question.
You should start, Gary.
Sure. Throw the young guy under the bus. No, I've been thinking about this. So I want to start with I think what's exciting about doing this kind of work. So the first thing is that it really is exciting to work with this scale of data and the relevance of the data that we're able to do. This is the only way that I'm able to look at like $1 billion worth of e-commerce traffic using Taobao in China. It's the only way I'm able to look at experiments involving 1 billion people to try to understand the effects of advertising, because sadly that's the scale that you need to start to learn things. So number one, it's exciting. Number two, I think as applied researchers, the context matters so much, and I think that can be an important distinguishing factor for doing good work, is understanding the institutions. And because these tech firms are moving so quickly, it's hard to be able to do that purely as an outsider. And having relationships with industry, working in industry, helps you to understand what are the most important questions and sometimes access data for that. And finally, just the impact that you can have is really exciting. Matt used the analogy of a tree falling in the forest. I don't want my research to do that. I think that the fact that this methodology I talked about, Ghost Ads, is used by so many companies in industry is tremendously gratifying to me. It's gratifying to see science being used to better understand how the world works by industry so that industry can make better decisions.
Yeah, I would just add to that. I have so far been less concerned about working with companies because I have chosen to work on projects where I feel it is really helping improve people's lives. And so I'm choosing those kind of projects. I'm not choosing projects where I feel like, okay, this is only helpful to the company, but not really making a difference in people's lives. So that has been my rule, how I pick. And I'm also not working on projects where I'm writing about what does this do for the company, right? So like, I mean, I think there are papers out there that then say something about, or that evaluate certain algorithms that certain companies use. That's not the kind of business that I'm interested in. And so I wouldn't take on these kind of projects as a researcher. That's my way to staying out of that.
Can I offer a contrarian view?
Please, by all means.
Great, because I'm going to anyway. All right. So I used to do more industry work early on in my career, and I've moved to completely working with open data for two reasons. The first thing is reproducibility. If you look in the top economics journals, at least half of these papers, no one can replicate them because the data belongs to Facebook or belongs to the US Census Bureau, and you can't get at it. And there's a huge replication crisis in economics, in psychology especially these days, and we just don't know if these papers are real or not. So that's one reason. The other reason, though, is for leveling the playing field. So when I first did this match between these patent to paper matches, it's about 18 million of these matches, I did it with the Web of Science because I had a license to that. And I thought about publishing those, but then I decided not to, because if I publish matches to the Web of Science, the only people who can use that are people who spent $100,000 to get a license. And a researcher from Stanford told me, oh, please, please, please post them because we have a university-wide site license to Web of Science. I'm like, okay, if I do that, then now everybody at Stanford can use this. But what about the researchers at University of Iowa? And so I've switched completely away from the Web of Science to the Microsoft Academic Graph. If you haven't heard of it, it's like Google Scholar, but you can download the data, all of it. And so now we have, literally dozens and maybe hundreds of researchers worldwide using these data. Someone just emailed me last night from a university I've never heard of in southern France. And that person can do everything that anybody at any university in the world can do. Because there is tremendous talent locked up in universities all over. And especially in the era of big data, it's becoming harder to get access to afford data, to afford computational resources. So anyway, that's my contrarian answer to you.
So actually, that's a perfect segue to a question I wanted to ask to the two of you guys, which is, it is my impression, or at least a pessimistic prediction, is that data science research might lead to more inequality or centralization, where the data and the access flows to a few name brand researchers who have a few successes, and then they get more and more access. So what will BU do? How is BU thinking about leveling the playing field, supporting maybe junior faculty, people that are starting up who don't have a track record but need access to these companies? Is this something that you have thought about, or you can offer any insight?
Actually, not specifically, I'm afraid, but it's a really good point, I think. One of the things that we do strive to help researchers understand is that a relationship with industry is not always the best thing that you should be doing, right? The points of intersection may be relatively small between open source, open innovation, the sharing of your information, and an industry perspective, which is more often trying to create a competitive advantage, right, through keeping things confidential. When that intersection exists, however, it can be extraordinarily powerful, but it has to be under the right terms and conditions that allow the researcher's main academic goals to be fulfilled. And if we can find those points of intersection, which can be complex, it's why Mike and I do the work that we do, this can be a powerful pathway to commercialization, right? So unfortunately, the way the economy works, one of the methods that we can move innovation into society to benefit society, this is what we're all endeavoring to do, is through commercialization. So it's a bit of a roundabout answer to your question, but that's sort of the perspective we take as we look at these situations.
Yeah, I'll give a very tactical response. I mean, first is you should always have your objective in mind, right? What are you trying to achieve? And then a simple stakeholder analysis of saying, okay, I'm trying to achieve this objective. Who else in the community, industry, government, whatever, is interested in this common objective of what I'm trying to achieve? Because then the motivations start to align. And sometimes having a person to bounce that off of, sit down with, and just brainstorm it a little bit helps you kind of understand a set of stakeholders that might see the world the same way you do. Secondly, when it comes to legal contracts, they're really boring and horribly written oftentimes and terrible to read. We will read those for you. And we'll help probably try to identify what are the key things you need to worry about. Hey, in this paragraph here, this means they're taking away your ability to publish on this. Is that what you want to do, right? And as long as you can have a clear understanding of what your objective is, what the stakeholders want, and what those contracts say, then we're empowering you to be able to make a decision about what's best for you and what you want to do in your research. So from a very tactical standpoint, we could probably help you winnow the field and understand and help you choose what you want to take on.
Azar has a question.
Thank you. As many students that Euros and you brought from your class. Garrett. Oh, it's Garrett's class. Yes, apologies. So I'd like to hear a little bit about education, about how do you see working with industry helping with education and programs.
I'll take this question. So one thing that I did not tell you is that I'm the faculty director of the MSPA program. And if I ask our students what's their primary goal after graduating, who wants to find a job in data science, right? Probably everyone. And part of that path actually seems to entail increasingly interaction with industry prior to graduation. So this is something that we have been thinking about very actively in our program. How do we motivate industry to engage with us, to provide projects, to provide data? Providing data is hard enough for research, where there might be a tangible outcome for the company. How do you do that when you say, I have a bunch of students, you've never met them. Can you give them some data from your company to do a project with, some chance of success? This is very difficult. Moving from that, how do you engage companies in actually hiring our students, getting internships, doing that in a framework that satisfies the million of rules that I have discovered BU has for engaging students with industry? So this is something we have been actively thinking about, but I think it's becoming an essential component, in the very least, for business education, but I think more broadly for data science in general. Companies will hire someone that they know. It's very hard for them to distinguish from a pile of data science CVs from someone that hasn't worked with them, whether they should hire this person. So I think engaging companies, placing our students, giving them this individual attention, and career mentoring from early on is the way, in my mind, to distinguish our programs. The curriculum is easy, comparatively. That's my sense. But I should not be answering questions, I should be moderating.
No,
I want to
no.
hear what others have
If
to
I-
say.
if-
But I just have very strong views on that.
If I may add to that, just as an example, so I teach an elective class to MBAs about applying behavioral insights. So it's more of a practicum class rather than a theory class. So because of the contacts that I have established with different industries over the years, at the beginning of the semester, I actually get projects from various companies that they would like the students to work on. And so for a full semester, my students are exposed to projects. So for example, this semester we are working with a large local Northeastern bank. We are working with Samsung. We are working with Save the Children and a few other companies. And so the students are actually interacting with the companies on a regular basis because they have to have their check-in, see they are on the right path. They're getting hands-on experience, and that makes it so that now the students have the contacts with the companies, and they also have, and because of that experience, the companies now see, okay, well, who is actually good? What do they already know about our problems? How have they solved them? And so, for example, last year when I had that class, which is a small class, one of the students afterwards went straight into an internship with one of those companies. And I think this is one way how we can use the contacts that we have with industries to bring that into the classrooms, into the education, and thereby also increasing the likelihood of being hired.
Thank you. I am afraid that it's already 12:15, and I would love to continue this fascinating discussion, but also we don't want to delay our next speaker.
lunch?
I encourage you to stay and engage with our panelists during lunch. So thank you all for attending our session.